Welcome to the Intelight tutorial on continuation of the user logic in max time. We're continuing our basic building of math functions and comparisons so that we can do more exotic apps in the future. This is where we'll begin, the controller, and we'll go to user programs, and we'll go to user program definition. So we're going to go into our user definitions and review the different parameters in here and the values that we can set up in program. Consists of a status screen. So we don't program this value. This is a return value on the line. So we can see if it's on or off or has a numeric value. The next column is our resultant, and we can set it equal to a local variable. The local variable is only good for one pass for this particular program. Global variables can be passed to subprograms and passed back or set to output pins. Of course, any input into the controller is also a resultant. And the index that goes with the resultant is the value or range. So we have 16 preamps, so it's 1 to 16. Detectors are 1 to 72. Global variables and local variables are 255. And we could certainly go through and pick all the different inputs. And we have a large range as we drop down. You can see holds, force oscillators. And down here at the bottom, you will see that we also have some additional ones. Moving over to our operators, we've already done the equal to A. That was one of the ones we did in the first tutorial. And the not equal to A, we played with that. And we did the relay logic, ands, ors, nors, xors, and so on. What we're going to move on to is down here on the math functions: add, minus, multiply, divide, and mod operations. So we're going to do some logic based off of those, and then we're going to go back to our comparison logic: greater than, equal to, less than, not equal to, that type of stuff. So we're going to have some fun with those different operators here in the next section. Our parameter A, first of all, can be a number, so we can put any number we want in there. A 0 is a no, a 1 is always a yes, or we can put a value with it. Those are our local and global variables, our red, yellow, greens, ons, nexts, and checks. And going down through a lot of outputs, overlap output colors, bit outputs. And we scroll down, and of course we can see the time of day scheduler, the pattern, action, day plan, schedule. So we can tie into this traditional time of day scheduler to turn our logic on and off. Scrolling down a little bit further, we get into the interval logic, and the interval logic is very nice for a refined selection. Like an interval on a preamp could be just the track interval or the exit interval. On a phase, it could be the min-green interval or the pre-clear interval. So we have all these intervals that we can pick from, and we can tie logic to it. The next columns is delay and extend, and we can program automatically on the same line delays and extends, and these are in tenths of a second value. So if you want to delay something by 10 seconds, you put 10 in there. And the last column is the description column. Now we're going to do a little bit of math. We're going to add A equals A plus 1, or we're going to set up a counting variable. It's one of the very first properties when you're doing logic is counting, so this is what we'll do next. Setting up our counting variable, first of all, I'm going to clear all the screens, and I can go through and select none and delete the numbers. But because I haven't saved it, I could just get out and come back in, and it'll be blank. So first of all, we're going to set up a global variable 1. And the operator is going to go down here to A plus B. So we're going to add parameter A to parameter B. And parameter A is global variable 1 again. And parameter B is going to be the number 1. So we're going to take 1 and add it to that variable each time. And I'm going to label this as a counting variable. And I'm just going to go down here and hit apply. So now you can see that we have a counter. Every tenth of a second, this gets indexed by 1. Our resultant value continues to count up forever if we want it to. And it's simply global variable, and we add 1 to it each time, and that gives us the index. If I wanted to talk twice as fast, I could make it a 2. But I'll leave it 1, and I'm going to go and create another global variable. This time it's going to be global variable 2. And I'm going to select a different math function. I'm going to collect the mod. So the mod function takes the global variable 1 and divides it by 10, but the mod is just the remainder. So when you divide 91 by 10, the remainder is 1. You divide 97 by 10, the remainder is 7. So every tenth of a second till it comes out even is going to be a counter. So this will be the 1/10 second counter. So we can basically, what we're doing is creating a loop. So we want to have a loop that goes around every tenth of a second. So we'll hit apply, and now we will have our loop. So now that we have our tenth of a second task and our loop logic and our counter, so here's our counter value. Every tenth of a second indexes up. We divide that number by 10, and the remainder is from 0 to 9. So it rotates around and around. So every tenth of a second, it loops. Now we can also do some comparison functions to this. If we went and said, let's create another global variable, like number 3, global variable 3. And this time here we'll do a comparison. So maybe we'll set A is greater than B. So we could go and we could set the global variable to a number and compare it to the variable, or we can go to global variable 2, which is going to be 0 to 9, and we'll say, put a number in of 4. So if it's 4 or greater, if it's greater than 4, it'll be true. If it's less than 4, it's going to be false. Looking at our program here, you notice that our first resultant is indexing up every tenth of a second, our counting variable. The next one is our loop variable. It's counting 0 to 9 in a constant loop, 0 to 9. And now we have an on and off, a half second on, half second off. So numbers that are 0, 1, 2, 3, 4 are going to equal false. And numbers that are 5, 6, 7, 8, and 9 are going to equal true. So a true in binary is a 1, and a false in binary is a 0. So that's what this resultant screen is pointing out to us. So that makes this global variable 3 a flashing variable. So we can tie that flashing pin to any output that we may want to use it as, or condition. So now we're going to go in and we're going to take a global variable 4 and we're going to do an AND statement, a little comparison that we had before. So we have a new global variable and we're going to AND our flashing variable to an output. So our flashing variable is global variable 3, so we're going to flash the phase PED clear for phase 2. So go into our outputs, and I will assign the global variable to the PED clear output, which is pin 34. So all I now have to do is go to my status screens, and when I go to phase 2 and the PED runs and it clears the walk, we'll have a flashing PED clear, and at that point in time our output logic will be flashing. So instead of being a solid one, we'll have a flashing. This PED yellow wire is usually not hooked up, so I'm not messing up my cabinet here. So it's coming up. We go next, so pin 34. We go through the walk interval, and now it comes on and it flashes a half second on, half second off. Thank you for watching this tutorial with me. I hope you found it fun. Please go back and try some of the other math and comparison functions. You can use these basic building blocks and change either the operator or the value and get different results. The next tutorials will take this on to some mini apps, which I hope you'll find exciting. See you then. Thanks.